Okay, all right. So this is the third session in the Threat Metrics 3 session masterclass series. For the folks who were here, they in the first not here rather. In the first two sessions, we spoke about just the digital identity network from Threat Metrics, what it is, how it is created. In the second session, we spoke about how that can be brought into the four walls of your enterprise and solve the workforce authentication use case in a better way to tackle fraud around IP theft and so on. And in the third session, I will be talking about now how to take this network that we have and then further extend it and bring additional data sets into the network in real time to better serve the decisioning that we already have in our network. Right? So for folks who missed the first two sessions, just wanted to quickly talk about who we are as a company. We've been in the business for quite a few years now. We deal with about 80 million transactions on a daily basis, about 2 billion on a monthly basis, over 30K websites, over 4,500 customers. So outside of Google and Facebook, perhaps the biggest network with respect to online user interactions that we get to see. Apologize for folks who are here in the second session that you have to see a repeat slide. But again, from a size standpoint, a typical month, we have about 2 billion transactions. Over 800 million of them are coming from mobile devices. And we track about 400 million digital identities across all of these interactions. So, and it's a global network spanning more than 200 countries, and millions of attacks stopped, and about 100 million new devices get actually added to our network every month. So it's growing at a very healthy clip. So, yes, it's a large network, that's great, but anybody who's dealing in the fraud space would know that no one company can have all the data, and the only way to actually get better at the newly emerging vectors all the time is to keep augmenting your data sets with everything that's out there. So in this session today, I'm going to talk about how we take this data set and actually marry it with other data sources which we don't see in the digital world. So the types of data and the solutions that we look to bring in are more tied to things that we don't see about a user doing in the digital world. So things around, they're in the physical world where they live, reside, associations that they have, and then also pushing it on the side of actually connecting with their mobile devices to do things like second factor authentication. So we can basically solve the problem in an end-to-end fashion when it comes to registering new users or authenticating users during logins. So to enable that, we launched this program called Threat Metrics Connect. It's basically a partner program that allows our customers to easily bring on these additional APIs and data sources. They don't do any of the heavy lifting. We own the contracts with these third parties. We develop the connectors. Or if you already have an in-house API, we have the platform to very easily create a connector over that API and then bring that data into our decisioning platform. And it definitely benefits our partners tremendously because they get access to the large scale that we have with respect to our customer base and the use cases that we see. The process to enroll in this program is quite straightforward. We currently are looking to basically work with best of breed vendors in the different data vectors that we are targeting. But basically, we have a process where to onboard a new user, and the end result is a connector that we create with a partner that gets added to our Connect program. The approach that we are following is to create prepackaged solutions on top of our network, leveraging this infrastructure. So what I'm going to talk about today is basically the step up, the first three boxes here up here. Second factor authentication, doing identity verification, and then leveraging mobile carrier data for carrier ID. So the rest of the session is going to be split into these three solutions and how they actually work on top of this integration hub. There are a bunch of different slides to cover. So I will try to, at the end of each solution, summarize what we spoke about. I'm not going to get into too much technical detail on actually how to make things run, to run a particular solution, but the goal is just to give you a sense of what that solution accomplishes. All right, so second factor authentication or step up, it's not a new thing, everybody does it. Basically, if you see that a user for some reason is not checking all the boxes with respect to their risk profile, you might want to step them up and verify whether they actually have access to something like a mobile device that they registered with you when they first signed up with you as a customer. So there are various providers out there, but what we see in our customer base is, since we end up being the front for the login transaction, whenever a user is logging on to any sort of a digital property, we see that transaction. It's a natural fit for us, for our customers, to say that, hey, you don't just tell us that this particular user is higher risk and you want to step them up, but also help us step them up. So what we did was we went out and formed a partnership with a partner called Telesign that actually helps us with delivering the one-time passcode to a user's mobile phone. So we can actually, along with knowing the risk profile of that particular login transaction, if we do want to step them up, we can also do the step-up piece of the transaction. So one thing to note here is, yes, it is, it is applicable just primarily for login transactions, but doesn't stop there. The step-up capability that we have is flexible enough that in the life cycle of the user transacting on your digital property, whether they are trying to add a new email address or make some change to their account, if at any point you do decide that you want to step up the user and then verify the possession of the mobile phone that they have registered, you can actually do the step up through our platform. The key limitation here, though, is, as you can imagine, it doesn't really stop a fraudster from registering an incorrect phone number with a valid account. So, I, as a fraudster, might take over somebody's account and try to register my phone number with that account. It doesn't really stop from that, right? And we'll talk about how to prevent that in the second solution, which is the identity verification solution. But the assumption with StepUp is always going to be that the phone number that you've registered with a particular user actually does belong to that user, and you've done some sort of verification to make sure that it's not some sort of a fraudulent phone number that's associated with that with your user. So the key reasons to again implement this with us is one thing we see repeatedly in our customer base is, if you want to step a user up, you do want to know that they are a riskier customer, right? So, and then that process of determining the risk gets done in some sort of an offline or a different system, and then marrying the two systems together is usually an operational overhead, where you got to stand up the infrastructure that takes the risk decision, and then stand up the infrastructure where you can deliver the passcode to a user's device, validate the response that they're sending back, and do the retries and all of that, right? So by actually doing the step up through threat metrics, you remove all of that operational overhead. You have one single integrated policy that basically looks at the risk profile of that transaction. And then if in the policy there is a rule that says if it's a risky, then do the step up. And then we manage the process end to end. So the side benefit of that is that you actually reduce unnecessary step ups. If you've seen the particular device multiple times with that account and everything checks out, there's no real need for you to step that user up. On the delivery side of step up, we benefit from our partners' reach and reliability and global network that they have. So on that end, basically we support one-way SMS, the classic way where you get a passcode on the user's phone and they go and enter that passcode on your website to verify. We also support delivering the passcode using landline or voice call. For folks who don't have or don't want a text message, we can have a call made to their phone to deliver the passcode. And there is also a two-way SMS capability, which is less frequently seen, But basically what that prevents is that it doesn't need the user to enter the passcode anywhere on your website. They can just respond via text saying, hey, this is me, and I respond with the passcode via text. So you don't have to stand up another website to accept the user's passcode. Okay, so quickly from a workflow standpoint, for the one-way SMS, is the user basically comes. Oops, my mouse pointer. All right, so up until this point, where step number 2 is the standard login transaction. What has happened until that point is the login page was shown to the user. They enter their username and password, and you made a call into threat metrics, and we said it's a risky transaction. You should step them up, right? At that point, what you would do is just make an additional call into threat metrics. That an additional call is where you would actually pass in the user's phone number that you want a passcode delivered to. And then we take it over from that point. We make an API call into Telesign. We generate a passcode, make an API call into Telesign, and then Telesign will deliver the passcode to the user's mobile phone. And then we wait at that point. There's timeouts and everything that you can set around that. But as soon as the user enters the passcode onto your digital property, be it a mobile phone, mobile application, or a website, whatever, what have you, you make a call into us and send the passcode into threat metrics. We take care of knowing whether the passcode is expired or not, or whether it matches the original passcode that was sent to the user. And then we send back basically a yes or no result back to you that you can then use to either let the person go or block the user. Any questions so far? So note that behind the scenes, this whole process is actually enabled by our integration hub. This is all API driven. So we make API calls into our partner Telesign for sending the passcode, and then getting a result back on delivery of the passcode and so on. Okay, so the first solution we spoke about was just stepup. That is enabled by our API, our integration hub. The second solution is identity verification. The identity verification solution is very relevant every time you are accepting a user and registering a user in any workflow. They might be just an existing user trying to change account details, adding a new phone number, or you might be registering a new employee where that employee is just providing you details with their personal email addresses and then phone numbers and so on. Or someone's trying to make a payment or ship something somewhere. Basically, any transaction that's not a pure, simple login transaction, but accepts user data and registers the user as part of that transaction or as part of creating some sort of an account, you have to verify the user's identity. And what we do really over here is we basically have pre-built connectors to a bunch of different third-party data providers that cover various aspects of a user's identity, like email addresses, the phone numbers, your name and address, date of birth, social security, and so on. And as part of running the threat metrics risk scoring policy, so as let's say a user comes in and enters all of that data on your web property, along with checking our digital identity network to know what we know about the email address, the phone number, and the device and their behavior within our network, we will actually go out to third-party data sets and get additional data and tie that data in real time with our decision and then return you an integrated decision back. So, why do this with threat metrics? We've seen our customers trying to do this on their own already. Typically, we'll see somebody saying, hey, we have a compliance need where we have to verify the name and address match, or we also want to verify the owner of a phone number or the owner of an email address as part of account registration. So, we are working with some sort of an API provider. But what we typically very easily start seeing is, this whole space of the static identity data, as I call it, is extremely fragmented. There are many different vendors out there that basically span geos. The coverage also varies. There are vendors who specialize in email addresses. There are vendors who specialize in phone numbers. and so on. So it's easy to build that first API integration, but the moment if you're a global business and you're trying to do it across your entire customer base, it becomes very hard to build that second and third integration, and then do that in an integrated way along with your risk scoring, maintain that infrastructure, maintain those connectors, keep up with the version upgrades that the third-party vendors are creating, and so on. So, doing that through threat metrics basically streamlines this entire process. You don't have to worry about establishing contracts and vendors and relationships with multiple different third parties and creating those connectors and managing the infrastructure. We take care of everything. You basically see a simple rule with the name of the API that you want to leverage, and you're free to use that API. So from a usage pattern standpoint, the classic usage pattern that we see is the transaction comes into our network, be it a new account opening transaction or a payment or account details change. And based upon what we already know about that particular user, through our network, we will either pass or reject that transaction, and that is typically 80 to 90% of transactions that we are able to just give a decision based on what we know. For some of the transactions where perhaps it's a newer device or a newer user that we've not seen, or there's not enough history available in our network for that particular user or that device, then we might want to seek out additional data sets. And then this is where you would then have a rule configured in your policy that only for this subset of transactions you want to go and seek out additional data from third-party data providers to further help whether you want to let that person go or you want to do additional verification and step up and so on. So the key reason behind this pattern is it actually it reduces friction. Every time you make these additional third-party API calls, there's a cost associated with it, as well as time it takes to bring in additional data sets. So though we as a vendor return our risk score in a few hundred milliseconds, sometimes the third party might take a few seconds to return back. So doing it only for a subset of transactions just makes sense from that standpoint. It also reduces cost, so you don't have to do it if you don't need it. And so based on that, so far what we've done is we've tried to cover the key PII attributes. So let's talk about email addresses. So we've tried to build relationships with leading providers of identity data along each PII attribute. So what we will cover next is the type of data that you will see for the PII attributes that we have coverage for today. We have several others in the pipeline. I'm not going to talk about those today. So we'll basically focus on email and phone numbers today. So for email addresses, we work with a vendor called EmailAge, and we have hundreds of millions of email addresses already in our network, but we bring in third-party data to actually complement that data set to get the details around when an email was first created. Who is that email address actually registered to? Was that email address seen in other fraudulent transactions that we've not seen? So is there sort of tumbling abuse happening in that email address where somebody, with Google, for example, you can put a dot in your email address and use it as a separate email address, right? So are we seeing some things like that around that email address? So what about the social footprint associated with that email address? How many social media friends do they have, and is it a good enough indicator for us to say that, hey, this looks like a valid email address and not a fake email address that was automatically generated? So we bring in all of that data, and all that data is available as part of the risk policy. Just as in our standard rules, you can create rules and decision based off of that data. Next is phone information. So on the phone side, we have two aspects. One is just the risk score associated with the phone number, which is actually global. Again, we work with a partner called Telesign here, where we leverage their network and all the intelligence that they have built over the years by sending passcode to the different phones. They have derived things around like a risk score around phone numbers based on that data and additional third-party data sources that they have. They also know things like the type of phone. So you can know whether it's a VoIP phone or a physical or a landline or a mobile phone and so on. And there can be use cases where you perhaps don't want to accept VoIP phone numbers. So that data is available as part of the phone score API. And then we have the phone contact API, which is a US only offering today, that basically takes a user's phone number and then returns the name and address of of the person that the phone number actually belongs to. So very relevant when it comes to like even registering employees perhaps or users, where you want to make sure that no one's providing you a fake phone number. It's a real phone number. So especially in the step-up use case, where I was talking about a limitation that you had, where you should verify a phone number before you actually allow a user to associate a phone number with their account. So this API actually helps you do that. Every time you accept a phone number with an account or somebody's changing the phone number, you can leverage the phone score and phone contact API to get a sense of, is this phone number actually belong to this person that they claim they are, and only then allow them to actually go ahead with registering that phone number. A quick summary of the geo coverage. So the email data is a global data set. We can work globally. The phone score, risk score associated with phone numbers is also a global data set. It's available across the globe. Phone contact is currently a US only offering. I've been going quite fast with this whole section. I realize that. Stop me at any point if you guys have questions. But so far we've spoken about stepup, how we do that through our APIs. We started talking about identity verification and how it is useful to have all the multiple API connectors through us for the sake of simplicity. I spoke a little bit about just the email data set that we get to augment the data that we already have, and as well as the phone data set that we have access to. Before I move on to the last solution, I'm going to talk about just how the workflow for the identity verification actually happens. So the key thing to note here is it's seamless and integrated in the user experience. So your user, when they are actually interacting with your web property and registering or making any change, they won't see any difference. So they won't see another API call happening or their workflow stopping in between. So notice the page loads. The user enters information, sends the data, and submits. Right. So behind the scenes, our calls to any third-party API happen behind the scene. It doesn't have to wait for any additional user input or change the user flow in any way. The only additional thing that happens is when you're doing additional verification, like getting your phone number registration data or getting email data from third parties, it does include another second or 2 second worth of latency. But we typically see that to be okay because we're not talking about a login workflow here. It's a new account registration workflow. So we've typically seen 2 seconds worth of additional latency acceptable by our customers. Okay, so just real quick, a snapshot of how simple it is to use third-party data sets. So what you see on the left is basically a screenshot of a risk rule that we have in our engine. So just like any other rule, we provide an out-of-the-box rule that has a listing of all the providers and APIs that we have enabled for you. So you basically just pick the API, select the inputs that are to be sent into that API. Some APIs have some minimum required inputs, like if you're talking about email data, then you have to send in an email address and so on. And the results that are available from that API are directly mapped into the attributes in our engine. So you can do like age, velocity, pattern-based rules on the third-party data that you get within the policy that you have in our platform as well. And all of this happens in real time. This is not a batch data feed or data extract, right? I mean, it's actually happening in the same flow in which we are giving our risk score back to you. All right, I'm going to move on to the third solution. Any questions so far? Yes.
One of the earlier slides mentioned only 10 or 20% go back to your integration cloud. That was saying that 80 to 90% is because you've already paid that.
No, good question. So the question is, if you only, if only 20% of transactions are being sent through the hub to get additional data from third parties, for the rest of the calls, are you already making the calls? So the answer is no. The reason why the rest of the calls are not being sent is just because there is very strong signals around around that transaction being a good or a bad transaction already available in our network. So there is no need to do additional third-party verification. In spite of that, there could be a use case around, let's say, compliance, where, for bank, when you're doing a new account opening for compliance reason, doesn't matter whether it's for a fact it's a good, from a digital footprint standpoint, it's a good transaction. You still have to verify the name and address and association with that person. So for such transactions, you have the option of sending them over to to get additional third-party data. But for others, you don't have to. The key thing to note is the flexibility to do that is completely up to the customer. So it really comes down to where within your risk policy you embed the call to the third party. It's completely up to you on what percentage of your traffic you want to perform additional third-party verification on top of. Okay, great. Any other questions? All right, cool. So the third solution I want to talk about is carrier ID. So for folks who are not familiar with carrier ID, what we mean by carrier ID, it's actually nothing but an identifier that is assigned to anybody using a mobile phone. So the reason why this is actually so unique and useful is it's actually derived from the SIM card that is in your mobile phone. And it's uniquely associated with the SIM card and the phone number that the SIM card has. It's completely tamper-proof because it's tamper-proof because it's derived from the SIM. It's the SIM hardware. So no one can say I'm going to try and spoof the identifier. As long as there is a SIM card in that phone, the identifier is uniquely associated with that SIM card. There is no PII as such in the identifier. It doesn't have like a user's phone number or any address or anything like that. It's actually just a cryptic hashed string. So there's no PII concerns associated with that identifier, and it's very frictionless because since it's derived from the SIM card, the user doesn't have to do anything. In most cases, the user doesn't even know that the carrier ID or the identifier from their SIM card is actually being used to basically know whether this is a good transaction or not. It's completely transparent to the user. So I will talk a little bit about how it actually works in a sec, but the reason why this is very useful is we often see people do things like device cloning and then do I'm going to get a different device and put another SIM card in that device and try to use that for fraudulent transactions. So this will protect against that because as long as you use the same SIM card in the cloned device, it all checks out. It's fine. We don't care whether it's a new device. If you get a different device, or if you clone your device and put a new SIM card in it, the identifier is going to change, right? If you wipe your device completely and then reinstall and restart the device and start from scratch, really again doesn't matter because as long as the SIM card in the device is the same, we know that it's the same device. So the way we use this is actually wherever available, you can actually use this carrier ID to now do something like a silent step up. So imagine that you have users who signed up for any particular service with you, and you accepted a phone number from that user. Now the traditional way was to step up the user in context of a login transaction, and step up was nothing but delivering a passcode to a phone that the phone number is associated with it. With carrier ID, you don't have to send any passcode, right? When a user actually registers with a phone number with you, we can actually leverage the carrier ID capability to know that when the transaction is actually happening in real time, is it coming from a phone that has a SIM card with the right phone number in it? So it's almost like silent step up. So It's great at re-identifying customers, especially because now, you don't you know, it doesn't matter whether your customer has bought a new device, upgraded a device, or even just bought a new SIM card. As long as the phone number that you have registered for them stays the same, and the transaction is coming from a SIM card that is attached to that phone number, you can basically validate that transaction without even sending a passcode into that to that user. So I know it's a little bit of a mind twister to know how it actually works end to end. So I'm going to go through this process again in 2 steps, right? So there's basically two logical steps to using this carrier ID, right? The first step is to register a user, and the second step is now then do the validation in context of the transaction. So the registration step is just like when you would register a phone number for doing stepup. When the user registers an account or opens an account, you accept a phone number from that user. Now, at that point, assume you did the identity verification piece where you verified that the phone number actually belongs to the user that they claim they are. And so what will happen is if now this registration is actually happening through threat metrics, we will compute the carrier ID associated with the phone number. Now this is just a unique hash that we compute without actually calling any third party. And I'll talk about how that gets used in a second, right? So just based on the phone number itself, nothing to do with a SIM card or anything like that, just purely based on the phone number, we compute the carrier, we compute an ID, right? And then we store that ID with the user. So the validate step is where I'll talk about how that validation actually happens. Sorry. What happened here? Okay, so again, in the offline registration workflow is the user loads, and even the profiling, all of the header and the profiling happens on that page. So the user basically registers with you as a customer and gives a phone number, and based on the phone number, we are computing an ID for that particular user. These 2 steps, the profiling and the header enrichment, don't need to happen, right? You can simply just pass in a phone number and say, okay, I want to register this particular phone number for carrier ID. So just the phone registration step itself. So let's talk about now how, so based on the phone number, we computed the ID. Let's talk about how that ID gets used. I'm going to skip the online registration bit. Keep hitting the escape key for some reason. Okay, because the validation piece is the interesting part actually, where the magic actually happens, right? So, wow, this is not visible at all, huh? All right, let me just walk through this. Okay, so first step. No, nothing is animated. I think it's just the colors are completely washed out in this projector. Anyway, so the first step here is, imagine a user comes on their mobile device, they open up the login page, right? And at that point, they're simply trying to log into your website. They enter the email address and their password and hit login. But the transaction is coming from a mobile device, right? So this whole carrier ID capability is not valid on the online channel on the desktop. It's only for a mobile device. So they hit login. Now, behind the scenes, what's happening is, we provide an SDK into your app, or even if they actually visit your login page from the mobile browser, as long as the LTE, the data network on the phone is active, we kick off a background process that leverages one of our partners called Danal, that What happens in the background is based upon the SIM card in the phone from which the login is is happening. Our partner actually contacts the carrier in real time and returns the carrier ID for that SIM card. So this SIM card, this carrier ID that is returned, again, notice it's because of the SIM card in the phone that is trying to log in to your website. It is not derived offline or stored anywhere, right? It actually happens in real time. And this whole process actually happens in, in a few hundred milliseconds, literally. So, yes. So we don't, the JavaScript is not to compute the carrier ID. The JavaScript is nothing but it's actually doing a redirect into our partner's API. So it's actually doing an HTTP redirect into our partner's API that basically uses that to further redirect into the carrier's network that then returns the carrier ID associated with the SIM card in that mobile device. I don't know how they actually get it, but I just know that it actually happens through the carrier, and it's not based on the JavaScript. We're not computing the ID based on the JavaScript. I actually have a slide that goes into the details of the whole redirection process, but I figured it might be a next discussion, not for the first discussion on carrier ID. Yes. Yes. Yes, absolutely. So having, even if the user is transacting on Wi-Fi, having the mobile network switched on is required, right? So if the user is not on the mobile network, then then carrier ID doesn't work. And that's important because that's part of actually it being unspoofable and tied to the hardware and that's tied to the SIM card. That's why we need the mobile network to be on for that. So. So the magic has happened in the background. Basically, we went to our partner, and the carrier has returned the carrier ID. So at that point, what will happen now is the user has hit login page, and you made a call into us. The session API query happens, right? Now at this point, right, we will run our risk policy just like it were a regular login transaction. Now, based upon what we know about the user, the device, and everything in our digital identity network, we come up with a risk profile for that particular transaction. So notice, just like during stepup, you at that point in the policy, you have, as a customer, have the option of whether you want to leverage carrier ID or not, right? If you decide, I don't want to do any carrier ID business, then it's fine. We just return the transaction. You don't incur any additional costs. But at that point, you do decide that, hey, I actually do want to step this user up, and I want to use carrier ID as a way of doing a silent step up. Then at that point, we will actually make an API call into our partner to fetch the carrier ID. So until we fetch the carrier ID, there is no cost associated, right? The partner is computing the carrier ID, but unless we actually get the carrier ID from them, there is no cost to you as a customer. So when we fetch the carrier ID, at this point, we then compare the carrier ID to the one that we had cached in the registration phase. Remember, in the offline registration, when you first accepted the phone number from the user, we computed the carrier ID, right? So, and that was stored in our database. Now, when the transaction is actually happening in real time, the carrier ID was actually derived from the SIM card. That is what we match with the one that we calculated offline. And if that matches, then we say this is great, right? The user checks out, go ahead, let them in. So that's the crux of the process, basically. There's a lot of other variations around carrier ID, but if you just walk out today, understanding these two steps, I think that's a great first step in understanding carrier ID, right? So we did the offline registration, where we accepted the phone number, we computed the carrier ID offline, and then in real time, when the transaction is happening, with the help of the carrier, we derive the carrier ID from the SIM card, and then we match the two in real time, right? And that process is something that cannot be spoofed. You cannot tamper with that ID because for the matching purpose, the second time it's computing in real time. Right? So that's the carrier ID capability. I have a bunch of other slides around just the workflow, but I'm gonna skip those in the interest of time and where we are in this session. So I will stop here to take questions. Know that if you're interested in carrier ID, we're happy to have follow-up discussions. As you can imagine, this is not a straightforward implementation, so we have predefined policy templates for doing the registration. There is an online registration workflow, which I'm not going to talk about right now. So we have predefined policy templates to take care of the registration as well as the validation piece. And from an implementation standpoint, for you as a customer, you don't have to do anything. You just need to be on the right version of our SDK for the mobile app. There's no special implementation as such that is required. The entire process actually happens very transparently. So, yeah. Yes, yeah, you do. So we do actually return the carrier ID as part of our API response, along with everything else that we return. We will return the carrier ID as well as the match, no match result, and so on to you. But the ID by itself is not very useful. I mean, you're welcome to take it, cache it, do whatever you would. But the fact that it actually doesn't have any data, it's very completely anonymous and just a hash string. There's not much that you can do with it. Yeah. Any other questions? Well, great. Thank you very much, guys. Hopefully this was useful.